in this course we must see some basic aspects of on polymers. You have to know certain basic concepts. Last day I told you in general some aspects on material science, general materials. I mentioned there are three major members in the family of materials, of which the polymer is one of them. Now, I have already defined what is a polymer. Now, from here you can see polymer in this word, if you divide this word, break these words into two parts, poly and many. Poly means many and mar means units. In contrast to discrete molecules, polymers are composed of macromolecules of very high molecular weight formed by the repeated union of small molecules known as monomer. By virtue of their very high molecular weight, there is a large difference in properties between monomers and polymers, or that too discrete molecules and polymers. You will gradually come to know how much is the difference, and by virtue of their macroness, these polymers have certain unique properties which have placed them top of other materials, and we will gradually realize. Now, what are these unique features of polymers? Polymer materials over other materials, say metals and ceramics. The first and foremost point is it is very light material. Say if we want to manufacture some space vehicle or aircraft, the load is an important criteria. In order to save fuel and better flight efficiency, we must reduce the weight of the vehicle. If we take metals, you know the specific gravity of metal is very high. So, the weight of the vehicle will be very high. Sometimes we cannot escape, we have to use some metal, but effort has been given to replace that metal by polymers. Talking about ceramics, yes, there are certain special cases to be used at elevated temperature. Their ceramics cannot be avoided, ceramic materials cannot be avoided. Still then, polymer materials have been developed in such a way, so that these polymers can also provide a resistance to very high temperature. We will gradually see those things. So, the most important point is weight, that means the polymer should be very light, specific gravity should be very low. In fact, these polymers are really very light. If we look into the specific gravity of polymers, say think of commodity polymers which we use every day. What are commodity polymers? Say think of polyethylene, say carry bag films. Without carry bag films, today we cannot think of anything. If we go to market, we ask for some commodity, the shopkeeper gives the material in a thin film packet. So, that those are carry bags made of low density polyethylene. Think of wire insulation and covering, that is made of polyvinyl chloride. Think of certain toys made of polystyrene, lightweight as well as very cheap. Not only that, for packaging materials, packaging in the packaging field, these polymers are also highly used. So, these are the materials known as commodity polymers, and they are very light. For example, the density of polyethylene may lie between say 0.94 to 0.98, less than 1, specific gravity is less than 1. And to talk about another polymer, that is polypropylene, it is the lightest of all these polymers. The density of or specific gravity of polypropylene is around 0.92 to 0.93. So, this way we can make these materials will be lighter and lighter like this, and we can remove replace metals and ceramics in many useful applications. So, that is the very light in weight. We will gradually see large number of examples of these polymers. I am not going to crowd these points with the examples of polymers. We will gradually see, and time to time I will refer back there. Then excellent strength properties. Only the material lightweight in material is not sufficient enough. They must bear load. They must have adequate load bearing capacity. They must be mechanically strong. Tensile strength, tensile modulus should be very high. They should not be brittle. They should be tough material. It should not break. And sometimes we need some elongation properties also. So, in general we can say these polymers can provide. In fact, these are providing very excellent strength properties. Then unique flexibility. These polymer materials are flexible. You can bend a polymer item because it is flexible. Now, you have to correlate this flexibility with its structure, configuration, etc. How it becomes flexible, we will gradually see, because it is that day I was telling, it is the molecular bonding in material. It is the bond. What kind of bond is there? Those bonds are flexible. Say carbon carbon bond, you know, it is a flexible one. Carbon carbon single bond is a flexible one. It can rotate, you can bend it like that. It can undergo bending, flexing, etc. That is why that is actually available in these polymers. Very high specific strength. What is specific strength? What is specific strength? Specific strength is the strength, ratio of the strength to specific gravity of the material. That means, we are having a material which is strong as well as it is light. Think of steel, tensile strength is very high. Divide the tensile strength or tensile modulus or compressive modulus by its specific gravity, you will get some value. Now, you take one polymer sample, say even a natural fiber, for example, say jute fiber, its tensile strength is suppose 450 megapascal, its density is around 1 to 1.1 to 1.2 like that. So, polymers still lower density. So, since the density is low, specific strength is very high. Now, this is a material, this is a property, which is very much essential today in today's civilization, in civilized applications. We can get very high strength, but light. Today vehicles are, say automobile vehicles are thought of fully green composite. What is green composite? Made of a polymer reinforced with a natural fiber. So, it may be natural fiber, it may be synthetic fiber. If that fiber is used as a reinforcement, dispersed in a matrix, polymer matrix known as polymer resin, we will get a product known as FRP, fiber reinforced plastic. This is light as well as strong with high impact strength. If a vehicle hits some object, or if a vehicle collides with another vehicle, the passenger inside the vehicle will remain safe if that impact energy can be absorbed by the vehicle. That is not possible with metal. That metal can shatter and just pierce the passenger like a sword. Whereas, if this composite is light as well as it can withstand very high impact properties, it will not break in that fashion. So, that passenger inside the vehicle will remain safe even if the accident is very severe. So, these are the advantages. So, very high specific strength, this property we should not forget. Then easy processibility and manufacturing to any shape. What do we mean by easy processibility? Now, in our country or in worldwide, there are many polymer manufacturing industries. They manufacture some polymer materials, say be it is polyethylene, be it is polypropylene, it is nylon, polycarbonate, some rubber. Those are manufactured by chemical reaction in chemical reactor, and we get basic raw polymeric material known as virgin polymeric material, but that virgin polymeric material is not usable, is not useful until and unless we go through certain processes and include some functional additives inside this polymer before obtaining a final product. So, a product is a mixture of polymer with functional additives. Now, in order to get this thing mixture of functional additives with the polymer, we have to pass through certain processes. What are those processes? First of all, you have to make a mixture, a blend of these polymers with the additives. All right. After making the blend, a compound is formed, that is called a polymer compound. We will cover in the subsequent lectures those things, what is polymer compounding, what are additives, what are functional additives, what are their functions. We will cover gradually, but before that just I am referring in connection with this thing that needs the formation of a polymer compound known as compounding. Once the polymer compound is formed, then that polymer compound is passed through certain machineries, through another subsequent stages of processing to give a final shape to the product, that is known as fabrication. So, we have to go through processing and fabrication steps, which involve high shear force as well as elevated temperature. Do you understand? So, those processing machineries are, say, an internal mixture or a polymer blender or a two-roll mill for making the polymer compound, or a polymer kneader to make a polymer compound. After the polymer compound is obtained, prepared, then that polymer compound is subjected to extrusion, injection molding, calendering, compression molding, thermoforming. So, various processing techniques are there. We will also mention those things in subsequent lectures, various different processing techniques. And while going through these processes, these polymers can be easily softened, easily processed it can say, for example, preparation of a polymer compound. First of all, the polymer needs to be softened by application of heat and some shear force. Until and unless it is softened, you cannot incorporate the functional additives in the form of particle, in the form of fiber, and after incorporation it needs to be dispersed. So, that softening is very easy in case of polymer as compared to metals and ceramics. It is known to you. So, that is why it is known as easy processibility. Not only that, there are certain your production devices which can be made through solution processing technique, because these polymers are easily soluble in suitable solvents. Even there are certain polymers which goes easily into water. You can have water soluble polymers, for example, polyvinyl alcohol or natural gums. These are soluble in water, and some other polymers which are not soluble in water, but organic solvents are available in which it dissolve and we get a polymer solution. Once we get a polymer solution, we can utilize that polymer solution for making a product. Suppose you want to make a film, we can utilize that polymer solution in order to form that film. Is it all right? So, we can easily say, or we can very well say that these polymer materials are easily processable, and it can be products can be easily manufactured of any shape, which is not so easy shaping in case of metals and ceramics. That needs that needs very high temperature, huge installation of machineries. For example, you take an example of footwear, or even you take the example of this pen or this pen. These are made by injection molding process. Or you think of bucket, mugs, bowls, any type of thing, where we need to produce large number of items in a short period of time. So, we can have one injection molding which is connected to a molding assembly or shaping assembly, where large number of small molds of this pen or bucket, all those things are there. So, in one sort of injection, what is injection? You think of hypodermic syringe. A hypodermic syringe, how the medicine or fluid is injected into the body. The principle is almost same. So, in one injection you can fill the mold with molten polymer, then by cooling the mold you can after cooling the mold, you open the mold, you will get many number of say 32. For example, in one shot you can get 32 items. In footwear industries, if you go, you will see, and that is fully automated, no manpower is there. You just start the process, it continuously, and one cycle of this manufacture your molding might be say 2-3 minutes. Now, you think of the volume production, large number of production of those small units by injection molding. So, it is not so easy for any products made of ceramics and metals. That is why we can say these polymers are easily processable and manufacturable, and we can give any shape as we like. Next important point comes is tailorability. What is tailorability? You know who is a tailor, the role of a tailor, what a tailor does. What a tailor does? He cuts the cloth according to the shape, dimension in order to fit you. That is called tailorability. Now, why we call this polymer a very good tailoring material. I give you a simple example. Say you have in your hand say polyethylene, a polymer material, polyethylene. You want to make a fiber. Yes, you can do. Polyethylene is hydrophobic in nature. You want to make it hydrophilic. Yes, you can do by chemical modification. So, by doing some physical and chemical modification on a base polymer, you can get another polymer. That means, you can develop a new set of properties on a polymer having already existing another set of properties. So, your existing material has got a set of properties. Now, you can broaden the properties, even you can improve the properties. This kind of facility is not available in other materials. We can tailor it. Now, since I have told you this example of polyethylene, now polyethylene is termed as a plastic material. Polypropylene this is also a plastic material. Suppose you have these two polymers, polyethylene and polypropylene, you need a rubber. Plastic is not like that of rubber, that is a different kind of material having different set of properties. If you want to make a rubber, what you have to do? You can say, sir, we can make a blend of polyethylene and polypropylene. You will get a new product, sure, of course, you will get a new product, but that new product will have different set of properties, but that may not be a rubber. But you can develop a rubber from these two materials. How? For that, you have to go to its monomeric stage. You take ethylene along with propylene, polymerize together. Polymerize together by applying suitable conditions of temperature, pressure, catalyst, you will get a new product, that is a copolymer of ethylene and propylene, known as EPR, ethylene propylene rubber, that is a rubber. The properties of this EPR is totally different from polyethylene and polypropylene. So, you got a new material from ethylene, polyethylene and polypropylene. So, this is a kind of tailoring technique. There are plenty. If you see, if you keep your eyes and ear open, you will find that any of the polymers you come across that can be tailored to have new set of properties, or you can broaden the properties. You can broaden the properties means you can have a broad spectrum of properties, as well as you can increase the level of properties. Both the things you can do. Then corrosion resistant, we fulfill our demand utilizing the available materials, say metals. Now, metals are not resistant to corrosion. In order to prevent corrosion of metals, we take the help of polymer by applying a coating of polymer over these things, so that these electrolytes cannot get access to the metal surface in order to set electrochemical reaction which occurs in corrosion process. So, this is not that corrodable, but it degrades also, that is a different aspect. The polymer degrades in other through other mechanism, but metal degrades through corrosion. Then excellent durability, it is stable. We can have the stability properties at very towards to very high temperature. Say those are known as Thermo, resistant polymer. Sometimes we call high performance polymer. These thermoresistant polymer or thermally resistant polymer can be considered as high performance polymer. Then next point comes with biodegradability. What is this biodegradability? What do you mean by that? What is the necessity of that?
Compatibility with natural material.
Compatibility? It is not like
So
that.
biodegradability means so that it not accumulate in the environment like
Yeah,
salts.
yeah. Now, I give you the let me give you the background. Till 1980s of the last century, scientists were in a motive to develop more and more stable polymers. How much we can make it stable? To what extent we can make it stable? It should not degrade by environmental agencies like heat, light, mechanical impact. It should be stable for long time. Now, when this consumption of polymers is gradually increasing day by day, we find that after the use of the polymer, when the use of the polymer is over, what we do? We throw it away. Where to throw? Where to throw?
Useless.
Usually it becomes useless. When it becomes useless, we have to throw it. Now, once we throw it to the environment, since these are synthetic materials made of carbon, 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 hydrogen, carbon, nitrogen bonds, which are almost stable bonds, does not break. So, it gets piled up in the environment, causing nuisance, causing pollution. There is a lot of hue and cry, and the entire world, they very much care about this plastics, polymers. How to dispose it? There is a great disposal problem with these polymers. This thing was not thought of till 1980s by the scientists. Then people started realizing, when these problems started coming, no, this is not the proper thing. Probably we have to think of some biodegradable polymers, biodegradable materials. After our use, we can throw it to the environment. Environment will take care of its disposal. Gradually, it will consume without affecting the environment. It will maintain the eco-friendliness of the environment, and that is not so easy job. Okay. For that, of course, some biodegradable polymers have been thought of. How? What do we mean by biodegradation? That means degradation by bioorganisms, microorganisms. That means these polymers should be considered as their food for the microorganisms. They can eat away. Say, think of this naturally occurring material, say wood, produced by nature, or woody materials or plant materials. If it is just kept or exposed to the outdoor environment, it is eaten away by microorganisms, say bacteria, fungi, all these things. Now, how they actually degrade? Because you have to go little inside we have to go a little inside into the chemical structure, chemical formula, functional groups. Actually, those are attacked by those microbes producing certain enzymes. Those enzymes catalyze this process. This way we get the biodegradation and we get this material consumed by the nature. So, that is if required we can introduce mimicking the nature such type of functional groups in the polymer. So, the polymer will be biodegradable as well as it is strong, as well as it is stable and flexible as well as it is light. So, maintaining all those properties after our use, if this can be taken care of by the nature, then that is nothing parallel to it. So, we can think of these biodegradable polymers. Adaptability, these are related or relevant things, it should be easily adapted by the environment. You think of this car, today you see many of us are using car in India. It was not the situation 10 years back. Then after 5 years a new model has come. So, I like to sell it off or dispose it off. After that I will buy a new model. Where this will be disposed? Who will take it? He will say, no sir, I will not take your car because that is old. I will go for a modern recent model, isn't it? So, where to throw it, where to dump? The people, the human being, they do not have space to live. We are living in 2 tier, 3 tier. Now, in your hostel, how you are living in one room instead of 1 person, 2 person, 3 persons are living. So, there is no space for living space for the humans. Then where is the space for keeping all these vehicles? So, the necessity of biodegradation comes. So, who will think the responsibility is lying on you? Our days are over. Our days are over. We are dying, but you are the persons on which we like to transfer the responsibility to think of biodegradable materials, that to biodegradable polymers, which will be strong as well as stable, as well as durable, as well as easily processable, tailorable, all these things. So, this biodegradability, biodegradable polymers, this is supposed to come in a very bigger way. Tailorability means it is a means of or way of modifying the existing polymer to suit our application or to develop certain properties, so that I can get it. Suppose I need a flame resistant, fire resistant polymer, I do not have. I do not have that polymer. So, but I need this fire resistance property, I can develop it. How? Okay, you halogenate the surface or you add some fire resistant or flame resistant additive, yes, you will get a product which is fire resistant. That is a tailorability. As I told, this ethylene propylene copolymer, it is a rubbery material. I do not have a rubber. You think of if you go back to history, I am not very good in history. Somehow I passed in my school examination history, but during Second World War time, what happened to Germany, United States of America? They stopped supply of natural rubber to Germany. What they will do? They need rubber for your making tires. When this was stopped, they did not just remain idle. Within a year time, they developed synthetic rubber industry, Buna rubber, styrene butane rubber industry. They developed synthetic rubber. Before that, it was not there. So, it actually came in the say within 44 to 45, 1945, that time. So, that is a tailorability. Natural rubber, we do not have natural rubber, do not worry, supply is stopped, do not worry, defense people is here, they know if something is not available, fine, let me think of, I have to get out of this problem. How to get out of the problem? Now, you are a human being, you can think of, you can get out of the problem, that is tailorability, you have to tailor. So, here ethylene and propylene copolymerize you will get a material that is a rubbery material. We have polystyrene, we have styrene, we have butadiene. Okay. So, make a copolymer of styrene and butadiene, that is a rubbery material, rubber, and that is a substitute of natural rubber. And also natural rubber, the chemical constitution of natural rubber you will see, that is 1,4 isoprene, 1,4 cis polyisoprene. This is a chemical constituent of natural rubber, 1,4 cis polyisoprene, synthesized by nature, but this can be synthetically made in industry, in polymerization reactor. So, this is a tailorability. Clear? Cost effectiveness, cheap material. We can get 1 kg of this plastic, say a polymer, say for example, in 60 to 70 rupees, earlier it was less than 40 rupees, because of inflation today it is 70, 75 like this, cheap material. You can say, sir, metals can be available even less than 70 rupees, fine. But you think of a product, you can make how many pieces out of 1 kg polymer and out of 1 kg ceramic or 1 kg metal, you will get more number of items from this polymer. So, it is cost effective. Then, in order to know the science and technology of polymers, gradually we will go deeper and deeper this way. We have to know the structural features of polymers, because we are the scientist. Today there are certain existing polymers, but we should not remain satisfied with the existing polymers. We have to develop newer and newer polymers. Probably you have read yesterday's Telegraph newspaper. Have you read? Yeah, there is a report. Professor C.N.R. Rao is a national scientist, emeritus scientist at Bangalore. He said that there are two forms of carbon in the diamond and nanocarbon, like that can be deposited on polyvinyl alcohol. On deposition of this polyvinyl alcohol, very small, very small dimension, few billionth of a meter. So, that forms a composite, nano composite, strong. He is claiming strong and tough. 500 MPa. He is telling, claiming. So, we have to know the structure, we have to know the chemical formula, we have to know the structure, we have to know the molecule, we have to recognize the molecule. So, the structural features, you please look into this point: length of the polymer molecule, length means length of the polymer molecule, diameter of the polymer molecule. You think of, imagine some isolated polymer molecule, say polyethylene, like a string or a thread, a line like structure configuration. How long it is? What is the diameter? Then length to diameter ratio, L by D ratio. You can calculate the length of a polyethylene molecule. Just I am giving you some input. You take the bond distance between carbon and carbon, it is 1.54 angstrom, and a bond angle, suppose a fully extended polyethylene molecule look like this. Here is one C, here is one C, one C, 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 like this. This is the basic aspect of polymer molecule, isolated polymer molecule. So, it continues, okay, and hydrogens are there. I am not showing the hydrogens. Now, what is this angle? You know, 109. So, if you know this bond length 1.54 angstrom and this angle, you can find out the length between one end to the other end. Can you not calculate? If you know that how many the CC units are there, you can calculate. Suppose there are 1000 units, CC units are there, you can calculate. So, you take this as a home task for calculation of this length of this polymer chain. Then this dimension you can also calculate. A simple geometry, by simple geometry you can also calculate. So, this is the diameter of a polymer molecule, this is the length of a polymer molecule. Now, this length and diameter of a polymer molecule exerts havoc influence on the properties of a product made of that polymer. Clear? Then we have to know the molecular formula. What is the molecular formula? Chemical formula. From the chemical formula, we could know that it contains carbon, hydrogen or nitrogen or oxygen or sulfur or phosphorus, like this. Say, if you think of ethylene, polyethylene, it contains carbon and hydrogen. So, we can say very easily that it is a hydrocarbon material, it is a hydrocarbon material. And if we think of another polymer, say like this, having carbon, hydrogen, oxygen, another polymer I am not writing the whole molecule. So, these R and R and R prime contains carbon, hydrogen, this contain nitrogen linked to carbon, nitrogen linked to carbon, one oxygen is attached to this carbon by double bond and one hydrogen is there. So, we can know what are the atoms present. We know the from the periodic table where they are placed, we can know the difference in electronegativity of the atoms and that has influence on the properties of the molecule. So, molecular formula we know. Then repeat unit. What is repeat unit? Now, in the definition of the polymer I showed that this unit is repeated many number of times, n number of times along the molecular chain, along the backbone of the molecule, that is known as repeat unit. And this n is known as degree of polymerization or dP, degree of polymerization. So, if I know the value of n, then I can easily calculate the molecular weight of this polymer. Suppose for n is equal to say 5000. The from the mass of this atom of carbon and hydrogen, you can write it is 28 into 5000. So, this is 1 lakh or 140 kilodalton molecular weight. So, this is the repeat unit. It is repeating along the backbone chain repeat unit. Then functional group. Now, there is no functional group like that, as we know. Functional group we mean say a carboxyl group, I mean say a group like this, or you can write this way, attached to polymer backbone chain. Now, there you saw that it can have this is the functional group, carboxyl group attached to the polymer. Now, other functional groups might be OH, other functional group might be other functional group might be ether, other functional group might be halogen, other functional group might be this, so on and so forth. So, these are functional groups. You must know these functional groups. Functional groups mean definitely they have certain functions to play, remaining present in the polymer molecule. When that molecule is used for making a product, in that product these functional groups will play certain roles. This is one kind of thing. Another thing you see, say what is this molecule? Polyacetylene. Now, this is a pi electron bond, that means entire chain will have a cloud, delocalized pi electron cloud, which is extended along the chain. So, it can have some pi extended pi electron structure, that is also one kind of functionality. That means, this molecule in the center there is carbon chain, carbon skeleton, like this continues. Surrounding this carbon skeleton like a thread, it can have a cylinder of like a solenoid, that means this is pi electron cloud, pi electron surrounding this thing. That means, this carbon skeleton remains within the center of this electron cylinder. It will behave like a conductor. It is behave like a conductor, conducting polymer. It has come in a very big way in semiconductor industry, because it is processable. So, this is one example of polyacetylene. You can know polyaniline, polypyrrole, polythiophene, like this. So, these are the then. So, functional groups. Functional group means definitely those groups have certain functions to play. that is why functional group. Then molecular configuration in solution and melt. Molecular configuration I mean that you have to, in order to know the science, you have to think of an isolated molecule. Suppose if you remain in one room, in a big room, if you live in a big room, your behavior, activities will be of one kind, and if you are put along with few tigers, your behavior will be another kind. If you are kept in one room with very good friends, another kind, or odd friends will be another kind. So, that means your surroundings. So, that surroundings, how it actually the configuration, that means the geometry configuration. What is the geometry? Now, think of a movie house, very serious movie is going on, you have just watching that serious movie, you are sitting in a very attention position. You forgot that there are many people in the audience, your auditorium, you are watching that movie. That is one kind of configuration. Now, if you do not like that movie, then you will try to stretch your legs and hands and something like that. Sometimes you sit this way, that way, and you stand and this way, and you will probably those, you may not like that film, but your person sitting in your backside, he might be liking that film. So, you are disturbing him, so he will caution you, oh, what you are doing, please get out of this auditorium, like that. So, this is the configuration. So, this kind of molecular configuration, how it, the geometric disposition of the molecule, its segments, etc., etc., in solution and in melt. Kinetic energy, kinetic situation, dynamic situation. Then when it is frozen, it becomes solid. So, configuration in solid state. What is the configuration in solid state? Okay. Now, if a material is just frozen from its solution or melt, what happens? It will be set in position, but if it is annealed or slowly it is allowed to configure, then the organization of the molecule will be of different kind, molecular organization, morphology in solid state. We can have amorphous morphology, we can have crystalline morphology, like that. Here are few examples of polymers. These are few only, we will come across large number of examples, and the easy way to remember the formula, repeat unit formula of these polymers, you start with this ethylene molecule. Ethylene molecule, not this is not ethylene molecule, it is a derivative, ethylene molecule. Start with ethylene molecule, CH2, CH2. You can substitute one hydrogen atom by one functional group, two hydrogen atoms by two functional groups, or the same functional group, or all the functional groups, all the hydrogen atoms by different functional groups. Say you can get easily a polymer. What is this? This Teflon, polytetrafluoroethylene, Teflon. So, it is easy to remember. Polyvinyl chloride, why this one polyvinyl chloride? It is easy to remember. So, you have to make practice. Look at the formulas, you see there is nothing to discuss these things. Actually, I did not have time to give proper arrangement of these groups through certain software that can be, but I will show you here. Yield by DDC of polymer molecule is very high. So, now today I shall not start this one, next I shall start. From next day onwards, I will try to go little faster. Okay. Thank you very much.